Genetic algorithms arise from the theory of evolution. If you consider two different animals, they are more likely to reproduce if they are more likely to suit for survival. Indeed, if you die at the age of 12, you are less likely to have offspring than if you die at the age of 80. At each generation, a small percentage of the genes are modified randomly. This modification may lead to no substantial differences in the likelihood of an individual to survive. But if a modification occurs, this may lead to a less likelihood to survive, or at the opposite, give him a selective advantages compared with others. If an individual develops a color of his skin which is more like his environment, he is less likely to be detected by his predators. In this condition, it will be more likely to have offsprings. The offsprings will inherit from this color ability and are more likely themselves to survive in comparison with the one who doesn't have this color ability. Genetic algorithms try to mimic this kind of idea. At first, we initialize a specific state of variables. In our case, we will set up a specific number of neurons and layers, and we will consider random weights between each neuron's connections. We will next run a bunch of simulations, then select the most efficient neural network. At the beginning, it may seem that all neural networks we use are simply moving randomly, and they are most likely to be. In the pool of all snakes we use, we might be able, however, to find a specific one which found a way to get a reward more often than others. It could be because it turns right when the reward is right to him. We will select him for inbreeding and we will reuse it in the next generation. We will also reuse the weights it has for new generation snakes and slightly modify them. We should not modify them too much to keep the most information that the former snake has, but also apply a small random change in order for the neural networks to maybe find a new way to improve again its reward. This means at each generation that we are able to get more and more robust algorithms that are more likely to get the maximum rewards available. In our case, we use a simple static environment. But there are other algorithms which tries to create new structures like you can have for NEAT, for neural evolving of augmented topologies.